another live Q&A video, because in this video and in this live video I will answer your questions. I will discuss some topics, something like what is a resistant, what is a capacitor, and what is a transformer, and what is the types of transformer, everything. Okay, so keep joining me, and I will start my discussing. So basically this is the second attempt I am trying to getting live, because in the first attempt I don't know why the live did not visible to anyone. So this live, let me share this live first. Okay, so let me share it. Okay, so I just shared my link of the live, and now let's wait for some time. I know this is not the best time for live, going live, but I just experimenting that how what's which time is more engagement, I get more engagement. So basically this is a Q&A live video, and I think maybe I can start something discussing with you, because the live video is very good. What just I'm saying I don't know. Okay, so nobody is here right now, so let's wait for 10 seconds. Okay, okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, nobody has come. No problem. Okay, one anyone come? Hello. So basically I want to show you some going to show you a thing which is basically a motor armature. Okay, so let's take a look at this. So what is this? Is basically a motor armature, which is a DC, just like toy motor. This is from the toy motor, and you can see here there is a thick and thickest binding, but this motor doesn't come with this thick binding. I rebind it for more torque and more high ampere and hot appliances. Okay, so basically it can run on a high temperature, and during running, if it getting hot, it will don't blow up, it will not blow up. Okay, so basically for this I made that armature. First of all, that I showed to you. Next I showed you something. This is basically a box of a mouse I bought very long time, for very long time. Inside of it there is some components which I have. So basically I made these tweezers. These are medical tweezers. I bought them for my medical career, and I just wrap it with the heat shrink covering, that kind of thing. So it is now uh, what it called, it is now insulated from electric shock, and it it's now good looking. Okay, so that is why my nose is blowing even right now. Okay, so you can see here is a screw, a little screw. Okay, let me zoom it. Yeah, just see here, there is a little screw which is from my old mobile, and this is not the thing which I want to show you. Basically I want to show you a thing first of all, which is a box of resistant. You can see here, I ordered it from the Quartz Components, and this is not a sponsor video, but just I grab a best deal from then, so I show it to you. So this is basically quartzcomponent.com, and you can purchase your items from here. They are made basically a very good thing, and this packaging is very good. This is a thousand pack of thousand resistance, right? Here you can see register kit. There are 50 values in here. There are all the values. You can take a screenshot and check all of it, and you can see here 20 unit each. It means every resistant, every value in its 20 units. So basically I open it, and inside of it you can see here are many of them, right? There's many of them, and yes, these are good quality products. You can see here, you can see here these are very good quality products, and these are more of them. Okay, so basically what is a resistant, and a very good thing about them, which is this color code. They different here, so I can just take all those and keep it one part of this, and I can just put the MOSFETs and transistor in another part of this box, so I can grab this whole box for traveling purpose, and I can just I can just take this to another level, I think so. Here you can see this is basically a resistor. What is a resistor? Resistor is basically a component which resist the current and electricity, basically the electron flow, basically the flow of the electron. And here you can see there is some color codes. So basically the resistor is a carbon tube, like something like this. So basically it reduces the flow of the what it called, the electrons. So here is the here is my all resistant. There are thousand of pieces, and yes, they are very cheap from them. I also telling that this is not a sponsor video. Okay, so basically I can show you next thing, which is a capacitor. This capacitor is basically 50 volt and 330 microfarad, 3300 microfarad. So this is a capacitor. This is a very good capacitor. I made a capacitor bank, and with the LC circuit I talked about my past in my past videos over about this one. So this is a basically LC circuit which contains the inductor, which is L, and the capacitor, which is C. So this is called LC circuit, and this is a choke filter. And you can also uh, read a article about this circuit in my what it in my website, which is www.thewordworld.in. That is my website. You can read an article about this one. Okay, so basically there are a transformer. There are two types of transformer actually. In okay my In my lab there are two transformers, two types of transformer basically. This is one type of transformer, which is basically iron core transformer. See, this is iron core over here. You can see, over here, this one is iron core. Okay, this is iron, and over these are the ferrite core transformer. So you can see here, these are not iron, these are basically ferrite. So this is the ferrite core transformer. And what is the difference between iron core transformer and ferrite core transformer? Basically you can see here, the iron core transformer works on 220 volt and 50 hertz frequency, 50 to 60 hertz frequency. These two wires directly plugged in into the 250 volt AC supply, and you will get 12012 3 ampere output over these wires. So you can use a rectifier and choke filters like this, and you will get a very high DC voltage. I mean, not high, I mean it is a efficient DC voltage. So let me test it for you. Okay, so first of all, power off. Okay, so there is my light switch, the plug is from the light, and so the light turns off, and put these two wires over here, and after that I just turn it on, and you can see here it turns on. When it turns on, you can see here is sparking over here. Okay, so basically this transformer is now working condition, and these two wires are containing 24-volt AC 3 ampere supply. But I don't have a multimeter right now, because I put that multimeter in my lab, in my home lab. So I just show you that normal function of it. Just you have to connect these two wires with the full bridge rectifier and the choke filter, and you will get a very efficient DC voltage. So it is charged, and so let me connect it, and yes, it is now complete. And you can see also here is a indicator light which I added, and let's short it. Should I short it? Okay, let's short it, and it will like this. You can see here, this is very dangerous. And see, oh my god, this is welded. This is just welded. You can see here, this thing is just welded. This is just damaged, you see here. So I can do it once more, you know. This is very dangerous. Don't try to short a high power capacitor in your lab, because this is very dangerous. Okay, so let's okay, so let the LED turn off. So it will automatically turn off when it reaches the lower value of the capacitor. And you can see here is the ferrite core transformer. But in case of this transformer, there is one, there is a input which is high voltage input, and this is output which is low voltage output. This is a transformer for a 12 volt DC adapter. But when I put something like 12 volt in here, then it will short. You just see here, no, it just fall off, because I don't have any grabbing tool. So this is basically that one. And let me check if that this kind of charcoal sticks are conductive or not. I bought these charcoal sticks earlier, and these are basically from the drawing purpose charcoal sticks, something like this. They are used in drawing. They are very good quality, and let's check if they are conductive or not. Let's check it. Okay, basically, no, these are not conductive. Oh, no, yes, it is conductive. Yes, you can see here. Okay, let me show you to the with a very good thing, something like this one. I can show this thing with this setup. Maybe this will be great. And okay, so I just put it on. Oh no, it fall off and it just break. Okay, no problem. Just take this one, and just take this two wire over here and just okay, let me turn on the flashlight and let's check. Okay, I don't have any right now I don't have any what it called, that is basically the tripod stand I don't have, so there is some noise. Okay, so let's check it. Yes, this is conductive and highly conductive it is. Oh no, my wires are getting warm, and yes, this is conductive. Okay, yes, ow, 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 my wires just getting hot, I don't know why. But this is conductive, not as conductive as a what it called, that things comes from the lead pencils. uh, the that kind of charcoals are very efficient, and you can also sorry, you can also make a light bulb from them. Oh, okay, I have them. Okay, these are the mini charcoal, I mean this is graphite also. So let's grab one of them and let's find if they can glow like a light bulb or not. Let's try. But for try it, I just rotate my camera. That's why you can see my sorry, you can see my face halfway and my working halfway. Okay, so here is two wires over here. Okay, I know you cannot see it. Okay, so there is the lead, and I don't want to just destroy the whole thing, so I break it into two. And okay, so with this one, just put it over here. Okay, just like that. But it is broke. Okay, don't worry, I just added the small piece over here, and let's just do it. Yet it will work. It will work, it must be work. Okay, don't worry, it must be work. So keep patient. And okay, just uh, let me just take some wire from it. And where is my cutter? I had a cutter. Okay, there is a cutter knife. There is a knife. Okay, so let's expose the wires from here. Okay, after this, thank you Hitartho, thank you for the support. And just grab some wire from here. Okay, just grab some wire. And just wait, just please just wait. Okay, I just take two long wires, you can see here. So now this is the pencil lead. Maybe you can see it. Maybe this phone has the fixed focus system, so this does not like focus every points. So it is a very bad condition, I know. But just I will show it in my back camera. Just give me a moment, please wait. And okay, I done my setup complete. And just turn this opposite side. And let's just look at this one. Okay, you can see there is my uh, 1 second. Yes, there is basically the lead. Okay, the pencil lead. And I just connected to my 24-volt transformer, and let's turn it on. Okay, ready? 3, 2, and 1. Okay, just wait. I have to prepare for the firing hazard, so I just put this box. If it falls here and just keep just get fire, then I can remove that one. So ready? 3, 2, and 1. What happened? Oh my god, this is just okay. This is just awesome. Yes, this one is just awesome. You can see, and it is glowing like a light bulb. I can turn off this my light, and you can see. Okay, so this just disconnected. So how was that one? Just comment down below. How was that one? Because my poor wires are melted, but I can just maybe maybe do it once like this is very dangerous. Don't do it at your home. Oh my god, this one is, and you can see here my electrodes are just getting sharper and sharper. But how? Just see here, they are getting sharper. And what happened when I touch them? Oh no, I cannot see them. Just see here. Just see here. What happened? Yes. Oh my god. This is just oh. This is amazing. I think. How was that? Comment. Comment it right now. Comment it. Yes, this is a very. Oh my god. This is very high power and. Oh. My all electrodes are fallen, so I I just stop this nonsense thing. Oh, this is getting hot. After some time it will blow up. So basically I just shown you something. I showed you previously my engineering over this mobile phone. And what is this thing, this is basically a battery charger. Because I just burnt this original charging port, you can see here it is burnt, and I fixed another um, port here so it can charge. But it is I can just work with it like this. This is okay, this phone is okay. But I just tear this switch wires. That is why this is damaged right now. So hello. um Abhi, so now we are connected with 4 peoples. So where are you from and what's your name? You can comment down below. Where are you from watching my videos and from when? You can ask me any question if you want, and I can just show you one thing. You will like it. Just wait. Just wait for a second. Let me take this out from my bag. And yes, thank you Hitartho, keep supporting me. And okay, so I just grabbed my this thing. Okay, so you can see here, this is for my uh, next video plan. This is all the pictures and everything. You can just see there is a full bridge rectifier. This is some waveforms. There is AC sinusoidal waves, and this is after the rectification. There's this and this. Okay, after this you can see here is the equation x equal to 1 by omega c, where omega equal to 2 pi f. And what is the magic of this? There is basically why a capacitor cannot 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 pass AC current. Why? Because here is the calculation. This is the basically, I don't have any pen right with me. Okay, I have a pencil. So okay, let me grab the red pencil. Maybe it is on working condition. It is right. So you can see here, this is the XC, this is the resistant. Okay, this is the resistant of a capacitor. I take a capacitor and I connect it with a AC sinusoidal voltage. This is a polar capacitor, right? So what happened with this capacitor? Obviously this blown up, or this blows up, what is said. Anyway, so basically what will happen if we have 50 hertz of electricity, which is AC sinusoidal wave. Okay, let me take a pen. Okay, just give me a moment. Let me grab a pen from my um, pen bag. I have a very cool pen. You will see. Okay, this is a very cool pen. So this is basically fountain pen I bought. Basically this is the resistant of the capacitor, and in case of DC current, okay, in case of DC current, uh, the frequency, this is the whole equation, and here is the capacitance, and here is the omega is the 2 pi f, here is pi is the 3.14, it is the value of the pi. And let's calculate this one. Okay, so in case of DC, there is frequency is always zero. Okay, in case of DC there is always zero frequency. So in case of DC, 1, okay, so omega equal to 2 pi into 0. So when we multiply everything with 0, this result is 0. So omega equal to 0, and if omega equal to 0, then C with multiply with omega, obviously 0. So 1 by 0 equal to infinity. All right, this is infinity. Basically in case of DC, the XC, or the basically the resistance of the capacitor is infinity. So it is don't it does not short it or something. But in case of AC, suppose we have 50 hertz of AC current. This is 50 hertz. So let's calculate this one. Here omega equal to 2 pi into 50. Okay, so let me grab my calculator. That is why okay, this calculator is from my class 12th, and you can see that things over here, and you can see here the calculation, which is 2 pi and 50. So here against 2 into the value of the pi is average 3.14. okay, here is 2.14. So 2.14 and into 50 hertz, what is equal to 214, right? This is the value 214. So the value of omega equal to 214 for AC current. Now the XC equal to 1 by 214 into what is the capacitance. I suppose this capacitance is about 3300 microfarad. So into 3300. So what is the value of that? Let's calculate this one. So 214 into 3300. Okay, so it I just accidentally typed this divide, this one is okay, into, and equal to, this is the answer. Okay, so 1 by answer 706200. So 1 by 706 and 200. What is the answer? Okay, basically this is the answer. This is a huge amount. Okay, this is a huge amount. Basically for this one, the AC sinusoidal waves blocks in the capacitors. That is why when we use the LC circuit, the L is for inductors. And yes, how the inductors work? In case of inductors, uh, the basically formula is x the L very sorry, here the basically formula xl equal to omega L. So here the inductance is the omega is uh, 2 pi and f, and as the same there will be the in case of DC there is zero frequency, so 2 pi 0, so the value of the omega equal to basically 0. When we add 0 into 0, sorry, the inductance, it will be anything, so the xl will be 0. That is why basically the uh, resistant of inductance in DC current is 0. That is why the inductors pass only the DC current. And in case of AC, the formula is same, and it will take almost, you can see here, if we take this one, this 214 is in with it just multiply the inductance, which I think the 100, so you can see 21400, this is the resistant. Okay, so basically this is the resistant in case of AC. Basically inductor cannot pass the AC because of this resistant, high resistance. So after passing AC current from the inductor and then the capacitor, you can get a pure DC form, which is this one. And over here you will get, after this rectifier, after the full bridge rectification process, you will get this waveform, and before this rectification process you will get this waveform, something like this is a sine wave. And when it square waves, then it will look like something that this is square wave. But this does not matter what if it is square wave or the sine wave, it does not matter. The matter is, here is a LC circuit we have, and you can just make a DC voltage source like your battery pack. But you don't have a battery pack because you just have a 12 volt 3 ampere of this transformer, and you also have a LC choke filter, and I have a full theory on them. If you want to read this and if you want to learn everything, you can just comment down below. I will provide a PDF link for it, which basically made by me, which is, so this is the my exercise book, and you can see here there is everything about choke input filter, everything, and then everything about rectifier, everything about the full bridge rectifier, and everything over here. So I can provide you the PDF file for yourself, for your study. So I think that live is something, I mean, some point of helpful for you. So you does not ask me any question, that is okay, but I wish in future you will ask me any question regarding my videos, regarding my channel, and also regarding me. I don't hesitate, and you know what, I just want to talk to you and give you answers of your questions. So for today, that's for today. Bye bye, take care. I will come with a new video very soon.